The first problem we're going to look at is number 49. We have a bunch of data here. We asked the students in a large first-year college class how many minutes they studied on a typical weeknight. Here are the responses of random samples of 30 women and 30 men from the class. Question A says, examine the data. Why are you not surprised that most responses are in multiples of 10? Are there any responses that you consider suspicious? So I would say most people just happen to round their answers to the nearest 10 minutes, so that's why they're in multiples of 10. I do think that the 300 looks a little, 300 and 360 looks slightly suspicious, like they could be exaggerating. That's a lot of minutes to be studying every night. They seem like pretty far away from everybody else's responses. So those kind of make me suspicious. Now, making a back-to-back stem plot is going to take some time. So I appreciate all of you who did that and actually worked it out. Let me start with the men. So the first thing I need to do is write all of these numbers in order, which is going to take a minute. So I'm starting with 0. I'm going to cross them off as I'm writing. I have 0, and then I have a 30, and then I have a 30, and then I have another 30. And I'm going to keep going. You can see I'm crossing these off as I go. I've gotten all the way up to 180. It looks like I have 2 that are 200. So I need to write both of those down. Next, I have 2 that are 240. And then I have 1 300. All right, so before I even worry with the women, I'm going to go ahead and make the stem plot for the men. So it's going to be a back-to-back stem plot. So that means that the stems are going to go in the middle. And let's see, I'm reading the question again. You could just have 0, 1, 2, 3, etc. But you might want to split it. Sorry, I was thinking. You might want to split it so that way that things that are in the 100s and things that are in the 200s. So generally you want your stem to just be one number. So I can't really do 3 and 4 and 6 because then I'm going to have 12 and 15 and 24. I'm going to have 2 numbers in there. And so it'll actually make more sense for me to go by 10. So essentially, or go by hundreds. So essentially if you see a 2/3, that's going to equal 230. So it's the hundreds place is the number. So I'm starting with a 0. And I have 0. Then I have 30. So I know this is weird because that 3 is representing 30. So 0, 3 is representing 30. It's there's an extra digit out there. And then I have another 3, and then I have another 3, and another 3. I had 4 30s. And then I also have 45, so I think we're going to have to round this up to 50. We're going to round up anything that's so that we have 10s. Since 50 is halfway to 100, I'm going to start another thing. I'm going to split it. So sometimes you do split stem plots so you can see the shape a little bit better and not just have everything in one bucket. So I'm kind of I'm going to have a 0 through 49 bucket and then a 50 through 100 bucket. So here's 50, and then I have 60 and 60 and 60. 75 is going to have to round up to 80. So then I have an 80, and then I have a 90, and a 90, and a 90. Okay, this 95 is going to get rounded up to 100. So then I have 100 here. So I have 100, I have 120, I have 7 120s. So I had to have that many 2s because I had that many 120s. Now I'm at 150, so I'm going to have 150. 150, 180. Okay, and then I go up to 200. So again, I know this is a little strange. I'm like jumping right into the most complicated stem plot you can have. But see, these are both representing the hundreds. It's just that the first one is like 100 to 149, and the second one is 150 to 199. It just lets you split it up into a little, like, to more bars. So for 200s, I have 200 and 200, 240, 240. So there's 200, 200, 240, 240. And then I don't have anything in the 200s that goes above 240. And then I skip down to 300. So that is the stem plot for the guys. I need to do the same thing for the girls, which again is going to take me a minute. And what's weird about this is we're going to have to be going backwards. So let's take a look. I'm not going to write out every single of the women's one, like, with the recording. But for example, let's see, I have a 90 and I have a 60. Those appear to be my smallest ones. So notice I didn't have any in this category right here. I didn't have anything less than 50. So I'm jumping straight to here. I know this looks really, really weird because I'm going backwards, like I'm going to the left. But you do the smallest number first and then you work your way out. So it's just kind of like a reflection. So I have 60 and then I have 90. And remember, this 0 here is not representing the 0 at the end of 60. It's representing the hundredths place. And then I have a whole bunch of 120s again. See all these 120s? 1, 2, 3. This one has to round to 120. 4, 5, 6, 7. So I think I have 7 120s. So it's 120, 120, 120, 120, 120, 120, 120. So 100, there's that one. That's 120. And then I'm going to just like keep following this. There were 4 150s. There was a 170. Then there were a whole bunch of 180s. There were 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'd have 10 of those. Then there was a 200, and there were 3 240s. And there was one 360. And so that actually, because 360 is bigger than 350, that would actually be down here. 360. Okay, I know this looks really, really strange, but these are my back-to-back stem plots. So we need to talk about comparing them, because the question said, does it appear that the women study more than the men, or at least that they claim they do, and justify their answer? I would talk specifically about the center. So the center of the women is like around here, like 175. You could kind of find the medium. But for men, it's actually around 120. So because the center for women is higher than the center for men, I would say that the women do claim that they study more. This was such a strange stem plot. I think I'm going to add another page and show you a more normal one. All right, let's pretend that I have some test grades here. Obviously, these are not very good. Hopefully, this isn't real life. All of these have 2 digits, and so I would just use the first digit as my stem. So I have 61, 64, 67, and then I had 70, 70, and then 81, 83, 84, and 87. And you always have to have a key, so like 6/1 equals 61, and I would need to have some kind of title like test scores. So honestly, that's a lot more normal of a stem plot. All right, this question is asking for you to describe the distribution. Essentially, it's breaking down CSOCs for you. And normally it would just say, describe the distribution. But this is being nice and is giving you a little bit more direction. So they do mention some important figures in here. The figure below shows a histogram of the distribution of monthly returns for all common stocks listed on the U.S. market over a 273-month period. The extreme low liar represents the market crash of October 1987, when stocks lost 23% of their value in 1 month. Okay, so describe the overall shape of the distribution of monthly returns. If I'm just kind of like outlining this shape, I would say that it's skewed left, maybe slightly skewed left, because like this part is pretty symmetrical, and then there's just like that one outlier out there. So I would say slightly skewed left. Unfortunately, I'm writing on my laptop, so I would prefer to type this because it's a lot of words. And it's also unimodal. That's one thing you can bring up in shape. That means it has one mode or one peak, unimodal. What's the approximate center? Okay, so the key to this one is knowing the 273 months. So if I do 273 divided by 2, that gives me 136.5. I'm going to need to approximate this to the best of my ability. So if I count, let's see, I'm going to bring my laser pointer out here. 136. So this is like one number, this is one number. This is what, I don't know, maybe 5, so 10, 20. This is approximation. That looks like it's 30. So 30 plus 20 is 50. Plus another 50 is 100, and then plus 80 is 180. So 136 is going to fall inside this column right here. Do you like my lightsaber, by the way? So this column right here is going to be where the center is. So I'm going to have to say the center is between 0% and 2.5%. Because those bars are like landing halfway in between 0 and 5, so that would be between 0 and 2.5. Then the question says, approximately, what were the smallest and largest monthly returns, leaving out the outliers? So honestly, I think that these two over here, we don't know for sure, but I think that they're probably outliers. If I'm looking at kind of the bulk of the data here, the lowest one, I don't have an actual number. I have to say what it's between. So the lowest is between negative 10% and negative 12.5%. And then the highest is between 10 and 12.5%. Yep. Okay, lastly, this one is the one I think that most people had questions on when they asked. Part D, a return less than 0 means that stocks lost value in that month. About what percent of all months had returns less than 0? All right, I know I'm coloring all over this page. I'm going to bring out a highlighter. So I'm basically trying to figure out what percent these are, the ones that I shaded. Those are all the ones that are less than 0. So I know that there's 273. Oh, that is not the right thing. I know that there's 273 months total. So I need to find out what percent is less. So I'm going to like add up these bars to the best of my ability, which I kind of did earlier. This is probably like 2 and then 1, so I have 3 plus 5 plus another 5 is 13 plus 10 is 23 plus 30 is 53 plus, this looks like a little more than 50, maybe 55. So we're kind of maybe, I don't know, in the like 90 range or so. It's a little hard to tell. 90 to 100. It's an approximation. I think your book said it was actually 102, but there's like no way for us to know that it was 102 unless we had the list of data in front of us. So if I do 90 divided by 273, that's approximately 33% that were negative. Our next question is number 53. How long do people travel each day to get to work? The following table gives the average travel times to work in minutes for workers in each state and the District of Columbia who are at least 16 years old and don't work at home. So we have all of these data points. These are supposed to be minutes. It wants us to make a histogram of travel times using classes of width 2 minutes, starting at 14 minutes. So we actually kind of have to make a table here, which is going to take a little while. I'm going to set it up and then I will fill it in without recording. So they specifically said they wanted us to go by twos and starting at 14 minutes. So I'm going to have 14, and I like doing it this way, 14 to less than 16, 16 to less than 18. So that way it's really clear. Oops, wrong ones. It's really clear which numbers you are, sorry, I got distracted. It's really clear which numbers go where. This is not letting me erase for some reason. So I have 18 to less than 20, 20 to less than 22, 22 to less than 24. I think this is going to go up to all the way to 32, so I have to keep doing this all the way up to 32. This next part is the part that takes a little while. I'm going to need to find the numbers that are between 14 and 16. So I am skimming. I see a 15.9 right there, and then I think there's a 15.5 right there. So there are two numbers that fall between 14 and less than 16. And then I need to figure out how many numbers fall between 16 and 18. It looks like 16 and less than 18. So I'm going to skim. I see a 17. Oh, that's the wrong thing. I'll change it to a highlighter so we can actually see. I see a 17.9. A 17.7, a 17.6, and then another 17.7 up here. It looks like the rest are above 18. So there are 4 that are in this range. And I'm going to keep doing this. I'm just going to keep counting and keep highlighting until I have how many numbers are in each of these bins, if you will. Bins is kind of like the width, the little interval that we're using. All right, I have all of my counts done for each of those categories, so I just had to, like I said, go through and count. A little annoying, but it is possible to do. I'm going to shrink this so that I have some space. Ooh. And try to make a histogram down here. So the x-axis is going to be our travel time, and it's going to match our bins. So we have 2, 4... Nope, not starting at 2. I forgot. We are going by twos, but we actually started with 14. So I'm going to have 14, 16, 18, 20. So I filled in all of those. I should go ahead and label what this is. These are travel times. And then on the x-axis, I'm going to have on the y-axis, I'm going to have the frequency. I think I'll go by twos, because I think that that'll just be the easiest thing to do. The biggest one we have is 14. So I'm going to go up to 14. And I'm going to label this. If I had had more space, I would have written this vertically. But this is frequency. Of course, you should always give a title. So remember, title, tick, tick, label, label, label. So the title of this is... travel times to work. And I have the tick tick is just the little like scales. So I have the y and the x-axis scaled. I have those two titles. And then I don't think there's another label that I need to add because we don't have any kind of key that's necessary. So I'm going to draw bars. So 14 to 16, notice it had a count of 2. So I'm going to go up to 2. For 16 to 18, it was up at 4. And then for 18 to 20, it was back at 2. For 20 to 22, I had 8. So y'all, I'm looking at the table up here and just making the bars based on that. These are supposed to be evenly spaced. Clearly, I didn't do such a great job at evenly spacing these. This is why it's better to make a histogram using your calculator or a computer. Then we have 12. And then 5 is going to be halfway between 4 and 6. And then we have another 2. And there is the histogram. The second question says that the shape of the distribution is a bit irregular. Is it closer to symmetric or skewed? Describe the center and the spread, and are there any outliers? So, I mean, I know that this is unusual. It's not perfectly symmetrical by any means, but the thing is, and this is going to be true for a lot of stats things, this is roughly symmetrical. It's got some things in the middle. It's got some stuff on the sides that are lower. It's not perfect, but it is roughly symmetrical. And the center, it looks like it's going to fall between... We actually have the list, so we could find, I think it's near 23 minutes, but it's between 22 and 24 minutes is where the center is going to be. And then, yeah, as far as the spread, we could find the range since we have the actual numbers, or we could say the numbers vary. So the travel times vary from 15.5 to 30.9, like, because we actually have these numbers up here. There was our smallest and our biggest. So we could say that the travel times vary from 15.5 minutes to 30.9 minutes. And there don't appear to be any outliers. There's nothing sticking out on the side. All right, number 59 is going to be pretty quick to go over. Notice that we have these two graphs. It was split. If you had trouble reading it, it was like kind of split on the page. The problem was we have the strategy didn't pay off in 2008. The Philadelphia Phillies won the World Series, and maybe the Yankees didn't spend enough money that year. So the graph below shows two histograms of the salary distributions for the two teams during the 2008 season. Why can't you use this graph to effectively compare the team payrolls? Okay, here's the deal. Look here and look here. That's really all it is. Because the x-axes or the x-axes are so different, I can't really compare these very well. It wouldn't be fair to compare these because the x-axes are completely different. Last problem. All right, this was a long set of questions, but a population pyramid is a helpful graph for examining the distribution of a country's population. Here is a population pyramid for Vietnam in the year 2010. Describe what the graph tells you about Vietnam's population that year. Be specific. All right, so I feel like there's a couple things I want to notice when I first look at this. First of all, I'm going to highlight. Notice these numbers here in the middle. They start off small and then they get big. These are the ages, okay? And then the population in millions is the x-axis. So you'll notice that both of these distributions are skewed. Now, we are going to need to imagine what this looks like this way, perhaps. I'm going from 0 to 100. The graph looks like that. Because the 100, like everything gets smaller as the people are getting older. So that's maybe helpful to kind of try to envision it horizontally. Now, when you are comparing two distributions, you should be talking about seesawks, and you should use comparative language. This is a really big deal. I noticed that for both the distribution of males and females, the distributions are skewed right. So the orange graph and the purple graph are both skewed right. I'm also noticing that for the males, there seem to be more younger males than females, but then when we get up to about age 35, there seems to be more females than males, slightly. So that's going to make the center of the female population be greater than that of the males. So I've talked about shape, I've talked about the context because I was talking about the population of the males and females. There don't appear to be any outliers for either of them. The center for the females is going to be a little bit higher than the center for the males. And then the last one is the spread. Both of them have numbers varying from 0 to 100, so they have a similar spread. All right, I'm going to actually paste in the answer from the book so we can analyze it a little bit. Check out this answer. And by the way, I always give you odd numbers because I want you to check your answers, please. You should be checking them. Notice that it kind of goes through the things. It goes through seesawks. We've got distribution of age. Okay, there's the context because we're talking about age. Skewed to the right for both males and females. So I have talked about context and shape already. And now they say, because it did say describe what it tells you and then be specific, they added in meaning that younger people outnumber the older people. So you have to say what it means. Among the younger Vietnamese, there are more males than females. After age 35, however, females seem to outnumber the males, making the center of the female distribution a little greater than the male distribution. So now they've talked about the center. Both distributions have about the same amount of variability and no outliers. Remember, variability is another word for spread. So now they've talked about all of them. So not only have they talked about CSOCs, they also have given context and been specific about what that means for this situation. All right, our next set of homework answers is going to come from section 1.2. Specifically, this is going to go over number 49, 51, 53, 59, and 65.